One, two, one, two. Okay, it works. So getting back to the core topic, I'm gonna pretty much be showing code most of the day. It's not text, it's just pictures of text. So who am I? Like, I've been working with Ethereum for the past year or so. I've been working with multiple companies such as Boson, which I founded, Getline, where I was a technical founder, and today this talk is about the last few weeks of research and my work working with Civil. So Civil is also a sponsor today. So what we're doing is, yeah, those hot pizzas are very theirs. Like, big thanks for those. So Civil aims to use like blockchain to provide high quality journalism again, make journalism great again, instead of fake news. So, for example, in countries like China, you have a problem of censorship. Blockchain kind of allows sidestepping this. And the idea is that by designing specific economic incentives, you can avoid the tragedy of the commons, and actually everybody that uses this network is going to be getting richer because they provide high quality content instead of fake news. That's the main idea that this company is trying to prove. So it actually kind of works. They have like 250 journalists right now from all over the world, from places like Times and the New Yorker. They've got a 5 million investment, and they're giving it away, at least 1 million of it, to high quality journalists. All right, that's done. And for those who don't know, Ethereum is based on smart contracts. So for those who read in Java or C++, it's pretty much a class definition, right? You write your class, you write your functions, properties, and methods, and then you deploy it on blockchain, which is different. So you pretty much create an instance of that contract, of that class. This contract has its own separate memory, it has its own separate storage, but also the whole code of the contract is separately deployed. What that means is that all the instances of the smart contract are immutable and completely separate from each other. So why do we use those? How do we deploy them? First of all, we compile them into bytecode, which is then put into Ethereum, and the bytecode is run pretty much. And what you end up is having an address, a private address, that instead of having a private key that is controlled by the user, it is controlled by the code that was deployed there. So obviously, you can't exactly understand anything from the bytecode that's up there. So how do you communicate with the contract? Well, the compiler spews out those artifacts, those JSONs that you can see here. And those JSONs have every method and every function, every getter and every setter inside the smart contract. And by using these ABIs, you can then encode parameters and understand results and return from the functions that you call on Ethereum. All right, so we have smart contracts, we have ABIs, but why the hell should we use it, right? So this is another library which is called Web3. So Web3 is a library in JavaScript that is aimed at creating frontends. What you can do with it is create a completely separate website that has no backend. All the data, all the storage, and all the logic of that was done on the backend on the private servers of Google or Microsoft or Amazon are done on Ethereum. And so the user doesn't need to trust any kinds of backends or any kind of countries, simply because all the data is back on Ethereum. And since most of the Ethereum projects are open source, you can pretty much validate that the backend really does what it does. It's a pretty cool library. You can do a lot of stuff with it. Lately, CryptoKitties was pretty fun. It pretty much blocked the whole network, right? And the Web3 communicates directly with the node that you have on your computer. The node itself doesn't, for example, understand ABIs. So there's a lot of stuff happening behind the scenes in Web3 before it actually talks to Ethereum. But well, Web3 was created in a different time where the team was really small and there was not a lot of funding and not a lot of money. So it has a lot of errors and bad design. For example, it has no typing, which means that even if you have those ABIs, even if you understand what you're trying to talk to, the Web3 doesn't. So you create a lot of mistakes during runtime instead of compile time. For example, you want to try to call a function on your smart contract that is deployed on Ethereum. And it compiles. It's JavaScript. Obviously, it compiles, right? But when you call it, it's going to error out with not very descript error, or maybe that you have too many parameters. And we shouldn't expose user to these kind of problems. Those should be caught during runtime. What's up? OK. Another thing is that they also wanted to make it as easy as possible for people to start, which means, for example, if you have a function that takes a number, which in Ethereum are 256 bits numbers, that means that you take a floating point number in JavaScript and then convert it to a bigger number, or take a big number and then convert it to a floating point, meaning you lose precision, meaning you lose data. So they added an abstraction layer, which is called a big number, which means that they have an infinite precision for all those numbers. But then they wanted to make it easy for the developers, and so they ended up allowing, for example, to take strings. So you have a function that you think that takes a string, and you input a string, but it tries to convert it to a number because you thought wrong. And during runtime, you have really, really weird results, and you're not understanding what is going on for the next half an hour, and then you pulling your hair out. And this actually is a problem because unlike many other ecosystems, this actually leads to real money losses, right? Because developers, those contracts handle like what, $300 million, and Parity makes one small mistake and everybody is out of their money. This is really bad. Like, let's not do this, please. So here's the fun part. We entered TypeScript. So what is TypeScript? TypeScript is JavaScript on steroids. It's pretty much typing for JavaScript, which means that you take all those functions that are in JavaScript, you take all those functions that are in Node, you take all those packages that are NPM, and then you add definitions of what kind of parameters do you want. Do you want to have a number, maybe a string, maybe a Boolean, or whatever. And then it detects during compile time errors that you might have missed. And this is awesome. This resolves quite a lot of errors, not only in Web3, but also in multiple other projects that I've worked with. The fun part is that you actually, if you have an already existing NPM package living online, you can create types on top of it in a private repo, right? So what you end up is, for example, types for Web3, which means that you get smaller classes of errors. But then there are some problems with it because you get JSONs, not JavaScript, right? So how do you type JSONs? Well, it's not exactly easy. So there came ZeroX project, which has a great team of developers, one of which is Leon Logvinov. He couldn't be here, but he's around here in Warsaw somewhere, probably on a date or whatever. And what they did is they take the JSONs and using a master's templates, they create new classes for TypeScript, new types for TypeScript, meaning that all your JSONs, all your compiled Ethereum code is now able to be checked compile time instead of runtime. And that means that we decreased a number of errors that the users see by a huge amount, which I have no idea what it is, but it's really helpful. And also this allows you to make additional features, meaning Web3 has a lot of bad practices and it has a lot of weird design decisions and is all based on callbacks, right? But maybe you want promises or maybe you want something even more interesting such as streams. And by generating those typed contracts, you can add all those features. If you didn't use an ABI generation code, you would have to manually add those features for each separate contract and then type it manually, which is a lot of work. So what is a mustache? Obviously, the name looks like a mustache because of the curly braces, right? Mustache is a templating system. So what is a templating system? The idea is if you have a backend server that you talk to, and you want to have some HTML that is generated based on who you are and what are you doing, is you use a templating system, such as Mustache or there are some others I don't remember right now. I think Django has its own, and I think all the JavaScript frameworks have their own, and Python also has ones. But Mustache is different because Mustache is logicless, meaning there's completely no control flow. There's no logic in the templates. You only get a context that is not run during the template generation. And that also means that because of it, Mustache can be reused in multiple languages. And right now, 40 supported languages that have Mustache libraries, especially JavaScript, which we use, right? But templating is fun. It's not only for backend services. It also allows you to make code generators, such as we did one. So this is our template. It's a TypeScript class that is going to be run for each JSON we have, for each artifact that we deployed on the network. And it's going to run through all the functions that this contract has, and all the properties that it has, and all the events it has. And it's going to make some magic. It's going to add some typing. It's going to make it type safe, especially with added additional features. So we really dislike the automatic conversion from strings and floating points. So we actually enforce that our developers use big numbers. And this allows us to understand why an error is happening more often. Because with no non-descriptive errors of Web3, you pretty much have to guess, right? But if we remove a completely whole class of errors, you're going to have to think less. It also allows pretty nice developer documentation, meaning without those typed contracts, I always had to have those artifacts and those JSONs on another monitor and always looking at them, seeing what kind of functions do I need and what kind of parameters do they take. But now, my Visual Studio Code auto-completes all that stuff for me. So I pretty much just press enter, and I get all the cool stuff already in. As I said, we also promisified all the callback hell, meaning the contracts and the function calls are a lot easier to understand and a lot easier to follow the control flow. So instead of jumping through all the callbacks, you pretty have a linear flow with async and await. We also streamified events with RxJS. You can't really, since events are unending, right? So you can't exactly use promises, but you don't want callbacks. So what you're going to use is RxJS that allows you infinite streams on infinite events. And since you pretty much abstract events into streams, what you can add is better network handling. Because when you have a blockchain, there's this thing called block reorganization, which means that the main blockchain is orphaned because somebody has been mining faster in another part of the world. And then all those events, all those transfers and transactions that you did in the last 5 minutes are non-existent anymore. And since you're writing code, for example, that actually handles the money, you need to think about this and think about all those events that just now have been canceled, right? And if you streamify those events, you can create a better error handling. So, as I said, we've also added additional features to promises. So if you call a function, send a transaction to Ethereum, you also need to calculate how much gas the smart contract is going to use. And by default, it's not exactly supported. It's pretty much sets it to 0. So you send the transaction, the allotted gas is 0, and then everything breaks and the transaction fails, and you're pretty sad. So for each transaction that you send, you have to estimate the gas needed and then add it to the transaction and then do all the stuff manually, right? But if you generate the code for each function, you pretty much can hide it behind the abstraction layer. So each function call to Ethereum can do it automatically for you, and you don't even need to care about it anymore. There is also, when you send a transaction to Ethereum, you get a transaction receipt with all the logs and all the stuff that happened during this transaction, such as transfers, such as events, and all that stuff. But it's in binary, it's in bytecode. So as a developer, I don't exactly like dealing with bytecode. So we transfer it into nice JavaScript objects with arguments and all that stuff pretty nicely. Also typed, so when you get a transaction receipt, you already know what you're getting back. So I said about RxJS, and I probably expect that most of you don't know what it is. And the idea is that you have a stream of things, right? It's probably an ended stream or an unending stream of things. For example, we have here a star, a triangle, and whatever. And you add operators on top of the stream, and they manipulate it somehow. So for example, you can have a flip, right? Which obviously in this picture just flips the figures 180. But you can have more interesting things such as filters, which removes some of the items, some of the events, or maybe removes duplicates, or maybe debounces them. And it allows quite a lot easier control flow even than the promises. So here's an example of how it actually works. So the top one is we have, for example, a content editor. What you see is what you get. I'm actually going to put this on the Meetup website so you can have it on, back home when you need it. So for example, you're listening on the key up events, meaning the author is writing, right? And you want to automatically save what is he writing. So instead of saving on every key up, which means that it's going to lag the computer out, which means that you're going to generate a lot of network traffic and probably DDoS your own server. You debounce for every 5.5 seconds, right? And then only save. In our case, we just log it because it's an example. But you can have more cool stuff. So for example, you are in the front end, right? And you're talking to your backend APIs, and you want to spam all your users with some emails. So you get all your users as a stream. And then if something breaks, there's no network connection, you can retry 5 times. Maybe it worked, maybe it didn't. You can handle the error afterwards. All right, but you want to spam only the paying users because you want more money, you want to get rich. So you just filter the users that already paid, but you don't need all the users, you just need their emails. So you map the user object to their email, and then you don't want to do all the email sending on the UI thread, right? Because it's going to lag out your computer. So you have another backend, which is workers, for example, on Amazon, AWS, and then you send those jobs and register them there. You spam the emails there, and you get job IDs back, right? So you want to display them for the administrator that is spamming the users right now. But if you just display all the jobs, it's going to be pretty ugly. So you obviously group them by machine ID, so you know how many jobs are on your Amazon or your local storage or your Azure or whatever. And then you display it and see there's 1, 2, 3, and 4 network connections in this little stream. And it's all abstracted, and you as a developer can easily understand what is happening in the big picture. So RxJS is very clever, and it has a huge learning curve, but if you use it properly, it's going to be a big help afterwards. So here's what we did with our contracts. This top one is the same as this one, but this one doesn't use streams. The control flow is all over the place. What we actually want to do is we want to find all the articles that some kind of author published and then display them grouped by author, right? So for example, if you have a search function in your website. So I was reading this code half an hour beforehand, and I actually found a bug in this one because obviously I can't even I can't follow my own code flow, right? But then you have this one, which is very simple and it's pretty readable by anyone, even not me, and it allows easier code error detection, and it's so easy you can't even make errors here. So for example, we have newsrooms that allow people to write content, and we are listening to all the content that was ever proposed in this newsroom, and we want to filter out by the search result that the user is having on their website, on your browser, and then we want to check if the content that we're looking through is actually published and approved by the newsroom administrators. So we're actually doing another call to Ethereum to check if it has been approved. All right, so we have IDs of the approved content that has been filtered, and then we need actually to have this content back, right? Because Ethereum, you don't exactly want to have huge articles with pictures, so you have a backend or decentralized storage such as IPFS where you put all this data. So you resolve content that is on Ethereum to IPFS data, and then you group it by the author. So you have arrays of authors and they're all articles, and then you just display it. And oh my God, I love this. I love those APIs. And this was pretty short. I think we all pretty tired, so this is all I have today. And I'm saying that I am representing Civil today. They are based in New York. They're looking for a lot of front-end engineers. We're looking for back-end engineers, and we're looking for blockchain engineers. And they allow you to work completely remotely, visit New York, and pay a pretty nice salary. So if you're interested, go ahead and send an email to this guy below. He's gonna take good care of you. And I'll put this presentation back in Meetup so you can do it back home. All right, any questions?
All right, so I have a question about Civil because it looks like a really cool idea. So are the authors of the content motivated somehow financially for the accuracy of information, to provide accurate information?
Yes. What is happening is that you're going to have so-called token curated registries, which means that you have articles that are going to be posted on Ethereum. And through democratic voting of it by token means, so pretty much proof of stake, they can vote whether this article is okay to publish or not. And then you have another layer of people that verify whether this article is truthful or not, and then anyone can dispute it and say, hey, this is fake news. And then there is this huge democratic and arbitrage process that checks, and we're pretty much implementing courts in Ethereum.
Okay, all right, but then does the author have to provide the stake beforehand, or is it just that he doesn't get rewarded for the article?
Yes, so when you publish, it's not finished yet, but when you publish a content on a newsroom, what you have to do is provide some kind of stake. In this example is Civil tokens, right? And everybody has, all the newsroom journalists have a week, from, if I remember correctly, to dispute this article and say we don't want it here, right? And if they enter a dispute, they also have to put their stake in, and then the voting begins, and somebody loses their stake, somebody wins some.
Awesome, thanks.
Anyone? So one more question.
All right, so this RxJS you talked about looks really cool indeed. Have you seen things like that for other languages too?
Yes.
Like, I know you like C++, so.
Yeah, so RxJS is an implementation of a standard called ReactiveX, and they provide libraries for many, many languages, such as Java. I actually haven't seen a C++ one, but I believe it exists. And the cool thing is they have the standard of the operators that exist and how those operators influence the stream and how the observables and subscribers and all that stuff works. And so if you jump between languages, you can pretty much use the same APIs everywhere else. Actually, I haven't learned RxJS at all. I started in Java and Android, and I used it there. And I said, this is such a cool concept that I'm going to use it here in JavaScript. And it's pretty much the same, yes.
Okay. Any question about Civil or something else?
So how actually difficult is this to set this up, to be able to write RxJS on smart contracts?
What do you mean, RxJS? Okay, so most of the stuff has been solved by me and the ZeroX project. So you pretty much have to copy and paste our code from open source GitHub into your own and be happy about it. And pretty much you can do the same thing as we did here with your own smart contracts. It didn't take long, right? I had some experience with Ethereum, so that made it a lot easier. But it took around a week or two talking directly with the ZeroX project and doing a lot of research on my own. But handily, you can do it in a week or two.
Okay, thanks.
Do you pay in fiat or crypto?
I have an actual obligation to not talk about speculation, so I'm gonna stop you here. Like, I have this in my contract, do not talk about speculation, sorry.
Okay. So, any more? Anyone? Okay, so thank you.
Right, that's it. I wanted to thank you all for coming here. This is January. We all pretty much still have a hangover from the New Year's Eve, and I'm very happy to see you here and still till the late night, right? It means a lot to us, right? And hopefully, you and me and Roman and everybody else here, we are gonna start this blockchain community and actually create a lot of blockchain devs because this is such an interesting topic, and I actually love writing code in it. It's completely different than any ecosystem I've worked with. Yes, it's kind of annoying. You have a lot of errors and frustrations, but due to the limitations of it, it's so completely different than writing on PCs or telephones. And one last thing, I want to take a selfie.